Okay, so how do we solve something like this? We have a square, we want to use the square root property. We're going to solve this kind of thing. Well, if you look at the notes that I gave you right here, this is, let me show you the notes. If you go onto our course site, at the top of the Unit 1 module, you will find the exam, here they are, the exam number 1 notes. So go find the exam number 1 notes at the top of the Unit 1 module. So very first thing in the top of the Unit 1 module. And here's the part we need, solving x squared and no x to the first. So we have different kinds, right? We have x squared, x cubed, and x to the first, or no x to the first. Let's go back over here. Specifically, we have no x to the first. Did you notice that? This is part of what you need to notice on these problems. See how there's only n squared and there's no n to the first power? Do you see that? So that's important because we have two different kinds. As you look over these different questions, let me just show you. Let me just glance. This is a lot of the battle is learning to identify. So this is x squared, and it does have x to the first. X squared, x to the first. X m third, m squared, and m to the first. See how all those have the first power on those. This one also x to the first, but then number 5, only n squared, no n to the first, no m to the first here, right? Just a number, and m squared. So that's what's different. That's when you look at the instructions I gave in the notes. When you're solving x squared and there's no x to the first, what do you do? A little different process. First, you get the x squared alone, then you put a root and a plus or minus root over the number side. Let's do that. So it's a little different situation. So step 1, get n squared alone. So we don't get a 0. Notice. So let's take this over here. 4n squared plus 72 equals 0. Here's our wall of separation. Trying to get the n squared alone. So let's subtract 72 from both sides. So 4n squared is minus 72. Let's divide by 4. N squared, use your calculator. What's that? 18. Minus 18, right? Okay, so that's step number 1. We did that. Got n squared alone. Step number 2. So I'm looking back at these instructions. You have x squared and no x to the first. That's us, right? We just have an x squared and no x to the first. You get the x squared alone. We did. That's right where we're at. And then you put a root and a plus or minus root. You got to remember that plus or minus over the two sides. So I'm going to put root plus or minus root. So I'm going to take that n squared is negative 18. I'm going to go root and root with plus or minus. Don't forget that plus or minus on the number side. Okay, what do we do from there? Well, if you look at the instructions, it says when there's a negative sign inside of a root, we take out the negative and put an I, because it means imaginary. You can't have a negative in a root. That's imaginary. That's not true. So, and this cancels. So it just becomes n is plus or minus, and then that negative comes right to the front as an I. So it's I, and now it's just a regular 18. You see what happened there? Let me explain that. I don't want that just to be some math rule that I say so or the math book says so. Why? Well, you remember what square roots are. Like, what's the square root of 9? It's 3, right? You know that. And if somebody, a young child, asked you why, you would say because 3 times 3 is 9, and you'd be correct. That's the reason. 3 times 3 is 9. Now, if so therefore, what's the square root of negative 9? It's not real, right? You can't do it because 3 times 3 is not negative 9. And you may say, well, yeah, what about negative? Well, negative 3 times negative 3 is not negative 9. It's positive 9. You can't do it. You can't have two numbers that multiply to be negative 9, right? Two negatives would be positive. You can't do that. It's impossible. It's not real. So what we do, because this is not real, we say, okay, it's not real, it's imaginary. So let's just take that negative and bring it out. You can't have a negative inside. So we just take it out and say, all right, it's imaginary. That's what that I stands for. We're saying it's not real. And then you just finish the problem. What's the square root of 9? Now you can do the square root of 9 because you've got rid of the negative. You took it out and made it imaginary. So that's I times 3, or usually we say 3i. So that's why we do that, because it's imaginary. You can't have a negative in a root. There's no number times itself that's ever going to be negative, which is what a root is all about, right? Square root of 9 is 3 because 3 times 3 is 9. So there's no way you can have the square root of a negative number. It's not real. So we throw out an I, get rid of the negative, and then we just go on with the problem. We're saying it's imaginary. All right, so we got it to here. Now we have to simplify that square root of 18. How do you simplify square roots? Do you remember this at all? Let me show you. You have to break it down. If you break down 18, it's 2 times 9, and 9 is 3 times 3. So in other words, the square root of 18 is 2 times 3 times 3. Right? If you multiply 2 times 3, it'd be 6 times 3 is 18. Those really are the pieces of an 18. Okay, great. Now what? Now 2 3's inside, send 1 3 outside, and they're gone. So it becomes 3 root 2. They might say, that's weird. No, that's exactly what we do. Think about what just happened right here. What square root of 9 do you think? You know that, right? Square root of 9, what just happened? What is 9? 2 3's, right? Isn't that 9, 3 times 3? So 2 3's inside sent what? 1 3 outside. See how square roots are always doing that? 2 for 1. I call them a 2 for 1 deal. 2 3's inside sends 1 3 outside. That's what square roots always do. That's why the square root of 9 is 3. So same thing here. When you break down the 18 into 2 3 3, then you do the same thing. 2 3's in, 1 3 out. So it's 3 root 2. Okay. So a little review of square roots there. You remember all that? So and this is going to be 3 square root of 2. So there's our two answers. So the two answers are really positive 3i. You can put the I in the front or in the middle, doesn't matter. And negative 3i root 2. But notice what the words say here. If there are no real solutions, the answer is D and E. These are imaginary because they have the I. So they're not real. So really what they want you to say is D and E, does not exist. That stands for does not exist, meaning the real answer does not exist. There is no real answer. After all that work, the answer is D and E. But it doesn't always, sometimes if your final answer doesn't have an I, right? If the final answer was just, 3 root 2 and negative 3 root 2 and there was no I, well, then we would just put in that answer. But if the answer if it's not real because it has an I, it's imaginary, then we have to say does not exist. We're saying no real answer exists. That's what they're saying right here. So we would say the answer to this is actually D and E, does not exist. The other part's going to be the same. Whoops, I lost it right here. This part. In fact, maybe I'll just do it real quick. Except it'll be real. So what do you do? Step number 1. Get the m squared alone. So I'm going to add 225 to both of them. 5m squared is 225. 5, 5, 5, boom. M squared is, I don't know, let me use my calculator here. 45. Okay, so there's the m squared alone. And then remember what we do. Step 2, root n plus or minus root. So I take that m squared is 45, and I put a root with a plus or minus. Don't forget that plus or minus. A lot of people forget it. Super, super important. Okay, and so now what happens? Remember, these guys cancel. Hey, why? Because that's 2 m's inside. That sends 1 m outside, doesn't it? You see why that works? Remember, we talked about it's square roots are 2 for 1. So m squared is 2 m's in, 1 m out, of course. Okay, now what about square root of 45? Well, you know how to simplify that now, right? 5 times 9, 3 times 3. So the square root of 45 is 5 times 3 times 3. And what do square roots do? 2 for 1, 2 3's in, 1 3 out. So 1 3 comes out, and the 5 stays in. So 3 root 5. Notice there's no I here. Why is there no I? Because we never had a negative in the root, right? The only time you do the I thing, like we did right here, is when you have a negative in the root. Where did I say that? Yeah, well, it's up in the instructions right here. When there's a negative inside of a root, we put an I because it's imaginary, right? You can't have the square root of a negative number. It's not real. But in this case, we never had a negative inside the square root, did we? We said square root of regular 45. So those are our two answers. We type in 3 square root of 5, comma, negative 3. It's fine to have a negative in the front. You just can't have a negative inside the root. That's when you do imaginary. That's when you send out the I. So our answers are 3 root 5, comma, negative 3 root 5. Those are the two answers. By the way, a lot of students have made the mistake. Make sure that comma must be outside of the root. It's easy to accidentally, when you're typing in your answer, have that comma right here, this comma be inside the root. You've got to go outside the root and then put the comma. Make sure you watch out for that. So that would be the other answer. So here we got two real life answers because there never was a negative in the root. It was just square root of regular 45, no negative. So those are real life numbers. Those are real life answers. Whereas the last one, we had negative inside the square root. So we had to put out an I for imaginary, which meant the answers were actually does not exist. So really we could have stopped right here, huh? As soon as we saw that negative inside, we probably should have just jumped right there and said, does not exist, we're done. I was just wanting to show you all the steps in general. So there we go.